So we haven't started the recording part. Anyway, so what we are losing over is just one question. So in the attribute problem, the expression turns out to be a very pretty simple expression, which simply says it's a difference of mass multiplied by g upon sum of mass. So now the other variable is called tension. So to get the value of tension, again, which is also very, very important, what we need to do is we need to substitute the value of A, which we have got, into any of the equation. So I'll go with the equation 2. So I can say for tension T, 2 implies, what 2 implies? T equals to M1G plus M1. So we can take M1 common and it gives you G plus A. Now you need to substitute A, there is no other way out. But what is A here? And now you can realize that we can in fact take G as common. So what you left with 1 plus M2 minus M1. And this you can simplify and you will end up getting. Okay, let me do this step also. So your answer for the tension developed turns out to be 2 M1 M2 G upon M1 plus M2. And in physics, the term M1 M2 upon M1 plus M2 has given a very special name actually. And this name is called the reduced mass. So there is something called the reduced mass, and it comes with the symbol mu. And the reduced mass says that inverse of reduced mass is always sum of inverse masses. So because we have a system of just two mass, so we will just add 1 by m1 plus 1 by m2. So if we have a system of 3 or 4 mass, we have to continue this inverse addition. And it turns out to be, if you simplify, the mu is product of mass upon its summation. And this gives us the very precise way to remember the formula. It's 2 mu g. So for a two mass system, because that is what we encounter in this particular chapter, or in fact in physics, the tension developed is 2 mu g. And why we call reduced? Because it is a value which is less than both m1 and 2. So it's a reduced value. Okay. So now you will also learn that the product upon summation of any two number is always less than any of the number. So it is less than the minimum of the two numbers. So you can take some example, let's say 2 and 3. So if you take the product and summation, it will give you a number less than 2 also. And you will convince that this is 6 by 5 is 1.2. So that's why the term reduced is used. So reduced mass is the less than value than any individual mass. So if I take a 1 kg and 10 kg, the reduced mass will be less than 1 kg. So if I could take 10 kg and 100 kg, then the reduced will be less than 10 kg. So the reduced means less than the minimum of the two value. Okay, anyway, so this is mathematical stuff you can understand.
So this is for every problem. A reduced mass
Pardon?
concept. So reduced mass concept is for every problem or just for actual problem.
No, 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 it is for everything. Reduced mass is a way to denote this term. So M1, M2 upon M1 plus M2, we name by mu and we call it reduced mass. That's simple. So this is the expression. Like you can write this term as mu. So this will give you the uh, cleaner way of writing and to remember the tension force. Okay, so now if the tension is 2 mu g and mu is the product upon summation, so we can go on and solve the question for what is the force applied by the ceiling. The ceiling of the pulley must be applying 2T. Why? Because the pulley is experiencing T down and T down. And therefore, this force we can write as 4 mu. Now, these all are meant for writing in a subtle way. So, sometime this will be easy for you to keep in mind. This is easy on mind, we say. So, in one particular chapter called center of mass, this is going to be used very often. So, since we are done with the first problem, let's do some practice for just reinforcing the idea which we just learned. So, I will draw a very simple looking adult machine, and you know that the pulley cannot move. And then so if I say this is 6 kilograms, this I say 2 kilograms. So the quick question is, what is A? Of course, I will tell you to or encourage you to do it from the fundamental by writing the laws of motion. But if you have really mastered it in the tutorials, then I can say you can just go ahead and tell me the answer. So, what is A? So we know the answer is difference upon sum into
So can you
G.
calculate?
Yes. Try this in 2 minutes, not more than that. So what I'm looking for is find the answer for the acceleration.
So 5 meters per second.
Yeah. So it's a 4 upon 8, which is 5. Don't say 5, say G by 2. Always express the answer in terms of G. And don't take G as 10 unless it is mentioned in the question. If you really want to take numerical value, the value that we are permitted to take is 9.8. The value of G is 9.8 meter per second square. So when a question says that take G equals to 10, then take 10. It means that should be mentioned explicitly in the problem. Otherwise, however bad the calculation may be, you should take 9.8, and this is a good practice to go ahead with. Okay. Because if you don't have this practice, then you may commit a very severe error in various calculation of JE problems. So we take 9.8 by default. And 10 we take, of course, but it is always mentioned explicitly in the problem.
So tension is equal to 3G.
So tension is equals to, so this
3G.
turns G by 2, right? This is G by 2. And the tension is uh, 2 mu G. So 2 times 6 into 2, 12 by 8. right? So 3 by 2 into 2. So I'm getting 3g, right? You said 3g,
Sir,
right?
I have one. Yes, sir.
Yeah, correct.
So I have one question.
Yes.
So how to find the force exerted by the pulley on the wall? Does it include the masses of that two blocks as well?
No. Again, when you do the ABD, you only see the force acting there. So you should not be bothered about something else connected ahead. So now in the beginning, it is very difficult to understand that the concept of force comes from there only. So of course, the weight we hang that develop the tension. So what you experience is important, not what is connected there. So no one should be bothered about what you connect. You just stick to one thing at a time, and then just do the ABD without getting worried about everything else. ABD is the tool which will help you in getting answer. Now, what you are saying is the very common apprehension among students. I mean, they always remain confused because they never rely on the concept. They rely on their emotions. Now, to master this particular chapter, the first thing which you need to master is your emotion. Unless you will not master your emotion, you're going to make blunders. So, stick to the concept. What is concept? I mean, it's very simple actually. The only thing is you need to draw the ability and then solve. Everything else will fall in place. If I look at the pulley, then I'm taking pulley as massless by default. If the mass of the pulley will be there, I need to mention that also. So that's not an issue. So that force acting on the pulley is T, and this force we don't know something, so let's call it F. Now the pulley I'm taking massless by default, so I can say because pulley is not in motion, F must equals to 2T. That's simple. So the force that the ceiling, now again this is something connected, so this will also pull. The force with which you will pull the ceiling down is the force which will act on the pulley, the action reaction pair. And your answer is ready. Now the question is why you should bother about what is hanging there, because you need to realize that tension is the consequence of everything else in the system. So those forces are taken care by the tension, and so you need not to worry about it. Let's do one simple problem. So we have a pulley attached somewhere here. The rope is fixed at one end, and we have a pulley here, and the rope goes past on this pulley, and now we attach one block here. Let's call the mass of the block as capital M. But I'm giving the pulley also some mass, but it's a smooth pulley. And now, because pulley cannot stand like this, so I attach some connection to keep the pulley intact. Okay. So imagine it is some connection there. What you're looking is a diagram, simple diagram. Now the pulley will also have mass. Now this block cannot move because the other end of the rope is fixed to the some vertical wall, as you can see. But the block of capital mass M, like the mass of capital M, will be pulled by the gravity all the time. So can you draw the ABD of the block, bigger block and the pulley? Can you draw the ABD only? And if the pulley is smooth, We know one thing, that for a smooth pulley, the tension remains same for the rope passing over the pulley. So although the rope is going from bottom to the left over the top of the pulley, but tension will not change because it's a smooth. So when I introduce mass to the pulley in this particular question, it will not affect the tension part. It would have affected the acceleration part, but because it is not going to accelerate, so even that is not an issue. So now just believing the laws of motion without applying your any common emotional, you know, sense here, being very plain and very blank will help you. So just go with the very, like, basic fundamentals of ABD.
So what do you have to find
You have to
after that?
find, you have to first, okay, first you have to draw the ABD. The question is, what is the force exerted by the clamp on the pulley? Now this is called clamp. The question is, find force exerted by clamp on the pulley. That's simple question. So you want to try?
Yes, sir. We'll try, sir.
All right, go ahead and try this question.
Sir, is it T1 plus T2 plus mg?
Okay.
2T2 mg plus mg.
Okay. So now this will expose the some fundamental flaw in thinking process, and this is quite common, which I have observed. Okay. So what you said is not something which has surprised me, but something which I always expect. So I have seen that every student, they fail to understand very simple concept called vectors. Now we have spent a lot of time learning vectors, and what you again fail to realize that these are vector. The force is a vector quantity. So when it comes to the addition of these forces, they must follow the vector rule. And what you just did is you added like a scalar. So how big the blunder is? Can you estimate the quantum of your blunder? So the sole purpose of learning vector is gone here. And I really do not understand why we fail to understand the force as vector. So we have been discussing vector. So now the question is, are these forces acting in the same direction?
No, sir.
So now, because this big revelation which I just give you, with this revelation, can you tell me what should be the net force acting on the pulley? Can you guess now? Can you draw the vector diagram and then find the resultant of two vectors or three vectors?
Yes.
Yes, so go ahead and tell me. Now this chapter will expose your all your learning about vectors. And then you need to train your brain that many times you do the problems called the blind method of solving problems. Means you do not realize but you just solve because there's certain things occurring in your mind and believing it to be true, just go ahead. So you do not realize. And that's a very big thing, like every student undergoes this phase from the solving question to realizing problem. And that makes all the difference. Once you realize, you will never commit mistake. So many times you will also feel that okay, although you have solved so many problems, but in the examination you're not able to solve one even a single problem or very less number of problems. And the reason for all those differences is called realization. So as a beginner, we always undergo through this process called the blind method of solving problems. We do things blindly, like your brain is not actually thinking a lot. It is doing it by some very natural trend because the chapter is going on and you have some fair concept about it. You know the how to write things and you're just doing it. You're not realizing anything when you do so. And that's why I'm saying it. I mean, why I'm using this term explicitly. This is actually a very common psychological problem actually. So we do a lot more things just blindly. Like you drive, you ride a bicycle. So of course, when you ride a bicycle, you don't realize all the forces and why your bicycle is turning. Of course, you have never realized those things, and that is what we learn in physics. Realizing things which is already happening, and then trying to react to the situation. And once you do so, suddenly you will see that your ability will improve drastically. The realization part. So now here the force acting is of course tension down, one tension down, but one tension is left. So these are two different directions. You cannot add these two values. And of course the gravity. Now I have no idea about the clamp force because the clamp will also apply because we are doing the ability of pulley. So there is something called clamp force. Now how the clamp is applying force? So it must balance vertical forces. It must balance the horizontal forces both together. So definitely I can say that the two acting down should be balanced by the some upward force of clamp and the one on the left must be balanced by the some right direction of the force of the clamp. So here the clamp force we always represent by the two mutually perpendicular components. So let's call it Ry, let's call it Rx, the force due to clamp. And the other force is tension, the gravity, the tension. So whenever the clamp question comes, where you cannot see how exactly it is acting, then we have to take two mutually perpendicular components. Accordingly, we should take so that we can relate easily. And then we can say that Ry is nothing but T plus mg, and Rx is nothing but just T. So the net force by the clamp will be how much? Or the net will be under root of Rx square plus Ry square, and we have done all this in vector, isn't it?
Yes.
Hmm. So R is equals to, we can write as T plus small mg whole square. I have written opposite x plus T square. And now the T is not difficult to calculate because we know that this block is not moving. So this T must be equals to the weight of the lower block. So the answer turns out to be, so I'm just writing this directly, T is capital Mg. And this is I got from the equilibrium of the hanging block. So the resultant force turns out to be capital M plus small m. I'm writing G separately square square plus capital M square G square under root, because G square is common. So we can take G outside and then it turns out to be capital M plus M whole square plus M. Now this was the JE advanced question. Maybe JE means that. So you can see that, okay, it's not difficult. Just like you need to just open your eyes. So first thing that you always carry in mind that yes, I'm solving vector chapter. This is a vector equation chapter. And just because some questions are one dimensional does not mean you're dealing with the scalars. And that is why the direction, the sign convention is very, very important. So my 2 cents of suggestion, when you solve this chapter, is stick to the fundamental. Don't apply your brain, apply the rules and the laws of Newton, which he simply said. Okay, and once you do so, you will find that okay, every question you can do it easily. Now, what I said is very difficult. So, what I said, do this, you will find it always contradictory. That your brain will always try to off track you. It will tell you that okay, do this. No, no, this is common sense. Come on, write this, write this, write this, and you will get trapped. So don't listen to the brain because the brain is totally immature as of now. So give some time to your concept and then let the brain pick up those concepts and then you become blind. It means after tremendous practice, your brain will go in the automated mode. You start thinking naturally the correct way. So you need to train your brain for some time. Okay. Anyway, let's go to the next one. So let me expose you to the some ideas of laws of motion. Okay, what we can do now. Maybe we can do something like this. So just to reinforce this idea that these are vectors, let me just give you some. So we have a thread coming this way. We have a pulley here. And then passing over the pulley, we have a block. And then you attach a block somewhere. And let's call the mass of the block as capital M. This mass is small m. And again, let me keep the same question. It's flat. And this part, I am giving you extra information. This is theta I am giving. Now the same question. Can you find the force due to clamp? So you want to try this question? Oh, so let's solve this.
Yes, sir. Yes. Yeah.
So you want to try?
Yes,
Yes.
sir.
Go ahead.
Sir, I got the answer.
Yes, tell me.
Sir, my answer is G
Hmm.
under root
Hmm.
m square cos square theta
Hmm.
plus m plus capital M plus small m the whole square. This is all in
Hmm.
under root.
Hmm. Okay.
So can you show the previous page?
Okay. What did you say? You want to go to the previous page?
Yes, sir.
Okay.
So done.
Okay. So here again, the tension will act at this angle. The tension will act this angle. Gravity will act here. Oof. So now, if you do the clamp force, which is the way we did earlier, so you can just make it x and y. So you keep it x and y, and then just compare the forces. Let's call it ry. Let's call it rx. So in this particular case, the ry is how much? So if you look at carefully, this will, if you do the all fours together, we
mg
can
plus
include, yeah, just a minute. This tension we can bring it here, parallel to this, and n. So now you can see this better. So we know this angle is theta. This is t. So if you look at the forces carefully, which again we are doing the vector question. So we can say ry, which is acting above, plus t sine theta, which is acting above, equals to mg plus t acting down. So all the above the vertical force equals to, and therefore the ry turns out to be mg plus t1 minus sine theta, and the rx is definitely t cos theta. Now t is definitely capital M. So we know all these quantities. So now we can change this to mg plus capital mg1 minus sine theta mg cos theta. And I hope none of you have got this answer, right? So the r turns out to
I
be
got
under root.
RX as same, but RY I
Uh,
didn't.
correct. Now these things you will learn. That's not a big issue. But I know that where you will get stuck. So you can realize that just solving problem without realization is so dangerous. So you can always keep an open eye that when you solve numerical, what we should be very much careful about. And with these small tricks, J will trap you like anything. So you cannot realize much, and that's how the JE advanced works. It always gives you easy problem, but of course, the chance of committing mistake is always high. So I hope this is clear to all of you.
Yes, sir.
yes sir.
So I think you will take some time to come to terms with the vector concept. So vector you can revise, go back, because all the problems of equilibrium which we solved there, you need to revisit and again apply it here. Because the equilibrium problem and the Lami's theorem problem I'm not going to solve again. So I rely on the fact that you will go back and revise. So now we are done with the one simple problem called atom machine. Let's try to expand that method further. So I'll keep on switching between the one dimension, two dimension problem so that you can develop the sense of vector. Because unless you will not develop that sense, it's very, very difficult for you also. Of course, it will be difficult for me to teach, but for you to learn. So I'm creating a simple problem in which we have too many blocks on both the sides. It is not just confined to two blocks. Let me create one block here, one block here, and then we attach some again a thread here, and then we attach one more block here. I can keep on doing this. So maybe let me do in fact one, and then one more block here. So let's call the value as maybe m, 2m, maybe 3m, no, maybe, okay, maybe m, maybe 3m. Okay, that's fine. So now, can you tell me how many strings appearing to you? You can see here. Can you see the number of strings
Three.
here?
Three.
Three is the right answer. So we have three different strings, and they come in the segment wise. So they are not connected to each other. They're connected to the blocks and from block between the blocks there is strings are present. So the first rule is when you come across multiple string, then the tension we cannot take same for all. So we must take the variable called T1, T2, T3 because we have three separate strings. So first of all, your variable will increase. But still, the good thing about this particular question is that all block will move in one direction called y direction, y axis. So they will either move up or down. So it's again one dimensional motion. If you consider individual block also, it's a one dimensional motion. So now this is going to be pretty easy for you. So what I want is that before I will give you some easy way to do it, can you draw the ABD of each block and solve? Because all will have the same accession in magnitude. Okay. So you're supposed to find tension in each string. Let me designate the tension so that you can get the answer in the same order. I'm calling this as T1. I'm calling this pink as T2 and the blue as T3. Okay. So my question is find T1, T2, T3. Again, do not apply your emotion. Stick to the laws of motion. Draw the ABDs, write the equation, and the best way is always add the equation. You will get the acceleration easily, and from there you proceed. You will get some better answers. Can you do it? Do you want to try this question? Yes or no?
Yes.
Okay. So go ahead and try this question. I'm giving you 4 minutes to solve the same question.
So tension 3 is equal to 3 mg.
Which tension is 3 mg?
T3.
T3. T3 is 3 mg.
Yeah,
Okay.
sir, I
Great.
got 2 mg.
How much?
2 mg.
2 mg. Okay. So 5, 2, 3, 7. That's going to be a very complex answer, as I can see. So of course these answers are not correct. Can you do it again? I think you're not coming to the terms with that. You need to write equation. What you're doing is I don't know what you're doing exactly, but you're doing something which you shouldn't. Kind of you're trapped in some thought process. Like you're not coming out of the way I'm saying you to do. So we have four block. So have you written the four equation? The answer is no. You haven't written the four equation in fact. So there's a lot of problem going on. Like your guys are not actually trying to learn what I'm teaching, whether you have some your own agenda in mind, and you're carrying your own agenda. That's the problem. Okay. Okay. So look at this. Let me solve this question. So your struggle is now not going to get over, right? The first block is M. M. That's called the left block. I'm doing one by one. One, two, three, four. So this is M. This is also M. This is 2M. And I'm sure that you haven't even completed the ABD before solving. You were in so much in hurry to get the answer that you didn't draw the ABD properly. Mg, Mg, 2Mg, 3Mg. So let me write down every value. Mg, Mg, 2Mg, 3Mg. So how many of you have written all this ABD of gravity? Yeah. Then the tension. Now this is interesting. So we'll have T above and T below also. And this will have only above. This will have only, and this will also have the down. And this will have above. So now we have T1, T1. Then this is T2. This is T2. This is T3. This is T3. Okay, I'm done. And now definitely, did you identify the direction of acceleration?
Yes, sir.
So it will go down.
Yeah.
So all will go up. So all will go up. These two will go down. And because they are connected with the string, so the only way they will go up and down is by same value. So A. Now tell me, is your ABD correct so far?
Yes.
Yes.
Everyone? Everything is the same way? Nothing missed?
Yes.
No, sir.
Okay. Then maybe your answer may be correct. I need to check. A, 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 A. Now, what is the first equation? Can you tell me the first expression? The first ABD for this mass? What should I write here?
Sir, A is equal to T1 minus
A
Mg
equals
minus
to,
T.
what is this A equals to?
Sorry, A no, sorry, M is
That you can add later on. So first add the net force. What is the net force?
T minus Mg minus T.
T.
T1
Say
minus T.
yeah. T1 minus
T2 minus Mg.
minus mg, yeah, equals to
MA.
May.
Good. All right. So now this is the first question. What about this question?
Sir, it's 2Mg plus T3 minus T1 is equal to 2M.
Equals to 2. And not this one. Then
T2 minus Mg is equal to M.
ma. Say completely.
Sir,
So what about this?
Oh, sorry, 3Mg minus T3 is equal to 3M.
Very good. Now what you need to do next is just add all the values. If you add all the values, we'll see that this T2 will cancel this T2 because 1 is plus 1 and 1 is this T1 will cancel this T1. And okay, we have missed something. Yeah, this T3. Now all will cancel out. This is always a trend actually. So just you need to add all the values. You will see 2 mg minus mg, which is mg. So 2 mg and minus mg all cancels out. We have 3 mg this side, and this side what we have is 1, 2, 3, 1, 4, 3, 7. 8 turns out to be 3g by 7. Okay. So now we got a equals to 3g by 7. So what is T1 now? So we have to use some of the equation to get first. Okay, we can use start with a small equation like T2, and so T1 is difficult to get first, so we can get T2 first, which is mg plus ma. So g plus a is 3g by 7. It turns out to be 10 mg by 7. Nice. We got down to T2. Then we can get T3 also from the last equation, which is 3mg minus a, 3mg minus 3g by 7, which is 4, 3, 12 mg by 7. So now this is T3. And now because we have the value of T2 and T3, we can find T1 now. So you can choose any of the question, the top question. So T1 minus T2, which is 10 mg by 7 minus mg equals to m into a. A itself is 3g by 7. This turns out to be how much? This is 17 mg by 7 plus 3. 17 plus 3, 20 mg by 7. So of course, there's a very simple way of doing this. I will just give it later on, not now. You can do these questions mentally, and mostly you will also learn that laws of motion is done normally mentally. But before you do mentally, you first need to learn the basic first. If you have command over this basic calculation, then I will give you the tricks or maybe the advanced methods. So is this clear to all of you?
Yes, sir. So can you give
Oh,
one more?
pardon?
Can you give one more, sir?
Of course, I'll give till you will learn. So in fact, you should keep on doing till you get the confidence. Let me keep simple. And what I'll do is I'll just add one more. Okay, so this time I'm keeping it slightly easier. Maybe you can try. This is M1, M2. I'll always keep a bad value so that you can have some practice. So can you do the same thing? Let's say the tension on the above rope is T1, this is T2. So can you find T1, T2? And you will realize that before you go to find T1, T2, you need to first go through the acceleration process. So you need to find A first, and then probably from there you can get the T. So can I do this?
Yes, sir.
All right. So go ahead and tell me the answer.
Sir, I got acceleration.
Yeah, sir, I also got acceleration.
Tell me the expression.
Sir, it's
Sir, it's
G
M2
multiplied.
minus M1 plus M3 into G by M1 plus M2 plus M3.
Sir, yes, sir.
Just one minute. Once again.
Sir, it's M2 minus M1 plus M3 divided by
Correct.
M1 plus M2 plus
Correct.
M3 multiplied by G.
Yeah, correct. So that's correct answer. And if you realize that now that is something called realization. So if you look at the answer, it is very simple. You're adding the mass on the one side and you're subtracting the mass on the other side, which is again like the difference upon sum, isn't it? Do you realize this? So at
Yes,
the
sir.
end of the day, what you're doing is that on the output machine, we have two masses, one on the right, one on the left. On the right, we have two mass, M2 and M3. So you can just add these two to treat as one mass. And then you subtract the other mass, which is M1. And then you divide by the sum of all masses into G. And that's the answer. So in fact, no matter how many mass I introduce, you can always do the same thing. So the faster way of doing this is without adding anything is add mass on the one side, subtract on the other, divided by this all mass into G. And that is what we do for the actual machine. This formula is always true. So we can always create a concept called the system. So this two we can treat as one mass because they are moving together in the same direction. Understood? Okay. So now once you get the accession, the rule is simple. Now once I know the accession, I will only write the enough equation to get the answer of tension. So let's say I'm trying to find T1. So to find T1, I can write the ABD of either this block or this block. But I will prefer the one which gives me the simple answer. So I'll go for the block M1. So I will do the ABD now as per the requirement. And so my answer is ready. T1 is M1 G plus A. And then we will substitute the value of A. For T2, I will not write the ABD of M2 because I can get the T2 from here directly. Okay. So now the T2 will be how much? So T2 turns out to be M3, or it's going down. So I need to write the ABD equation of this because this is going down. So for T3, sorry, T2 only, M3G, I'll just do the ABD which I need. I mean, I will not do all ABD. So M3G minus T2 equals to M3 into A. And the T2 turns out to be M3 into G minus A. But because it's an add-to machine, so finding T1 is again a very easy job. And if you remember, I gave the format 2 mu G. The only difference is the mu will be modified. How? The all mass on the right hand side we have to treat as one mass. So what we write is 2, the left mass into the right mass upon sum of all mass into G. So you can see that this formula is so powerful that once you know this, you can find the tension in no time. So the M1, M2 should be replaced by the mass on the left and the mass on the right. That is the idea of atom machine. So every problem of any atom machine you can do by the same. So you can treat all mass on the left as one mass, all mass on the right as one mass. But this formula is only true for T1. So for T2, you have to go through the basic one. Now, so what I gave you just is the advanced method of doing the same thing. So now what we can do is we can do things very fast with this idea. Now let me come back to the same problem and let me give you the quick solution. Or in fact, you can do it mentally. So I can add the a directly here. So what I'm doing, I will just add this two marks, which is 3 plus 2, 5. Add these two marks, which is m plus m, 2m. The difference upon sum, which is 7m into g. And you can see that answer is 3g by 7. And I think we have got some answer here. So you can actually get the answer very quickly if you just understand that all the mass on the left and the right we can treat as one mass, and then the difference upon sum, the very basic that we did for the the very basic atomic machine, that we have to apply. And in fact, finding the T1, I can tell you directly what is T1. So it's 2 mu g. So what is mu here? The left mass, the right mass into g upon sum of mass, which is 8. M cancel, 2 to the 4, 2 cancel. So how much we are getting here? 2 mu1 m1 m2, so 3 to 5 2m g by 2. So T1 comes out to how much? Have we missed something? T1 is, no. So what we are getting Tn here? Uh, T1 is T2 plus mg, T2 plus mg plus m. So this becomes 17 mg by 7, 20 mg by 7. Yes. But if we are applying here T1, 2, mu1, m1, m2, so product of mass is how much? The mass on the left, 2m, this is 5m by m1 plus m2, 5 plus 2. Okay, it's my mistake. This is how much? 7. So now this answer turns out to be how much? Okay, nothing cancel out, so I just cancel it. 2 times m1 m2 by sum of the mass, which is 7m. I don't know why I wrote 8m. And then the answer is, I think we missed here.
6 5 G or 5.
But that's fine. So we have cancelled. So we got the answer 10 20 mg by 7. The same answer which we got here. You can see that only this two formula will reduce the effort drastically. So be it any situation of a very simple atomic machine, you can always apply this method to get the topmost tension and the acceleration. And once you have the acceleration, you can write the ABD of one particular mass to get the other information. Let's say for T2, I will just write the ABD of this one separately. So that will prevent me from writing everything else. So now I need not to write everything the way we did it here. So of course, this is called the naive way of doing it, but this is the way that one should know before you know the something advanced. Okay, I hope this is clear. So let's do the last problem before we wrap up this particular concept and go to the next problem. So before we go to any problem, the attitude should be mastered by every student. That's a very fundamental question. And this time I expect that you will get the answer quickly. So m, so 2m, and let's call this m. So can you find the acceleration tension in both these things?
Yes, sir.
Yes, do it. Do it fast. Now this time you know all the tricks.
Sir, acceleration is g by 2.
Three. Yeah. Just a minute. Yeah, zero is correct answer. That's correct.
Sir, T1 is sir, wait, I will have to- okay.
Yeah, T1 is.
Sir, 1 minute. Sir, 1 second.
Go ahead.
Sir, the tension 2 is 4 by 3 mg.
Yeah. So T1 is 213. 3 into 2 6 upon 4 into G. 3 mg by 2, right? This is T1.
Yes, yes, and T2 is 4 by 3, 4 by 3 mg.
Okay, so let me check quickly. So the A part is pretty simple. It's 2 on 3 minus 1, 2m by 4m, which is G by 2. That's easy. And T1 is 2m into 3m into G upon the sum of all masses, which is 4m. M cancels this cancels. So
Yeah, sir, I
T1
got
comes
3 mg by 2.
very good. And once you know the acceleration, because this will go down with A, so you have to do only ability of this block, not for all, to get the T2 answer. And then write the answer is mg minus T2 equals to ma. So T2 is mg minus A, which is g by 2. So answer is mg by 2 only. Okay. So T2 is mg by 2. This is what you got.
Yes, sir.
Oh. So I hope the basic attitude machine is clear to your brain, and probably you can attempt questions with greater speed and accuracy
So can you show
without.
the previous page?
Okay.
So 1 minute. Done, sir.
Okay. So the next question that we can do is, I hope you must have done this kind of question in tutorials, isn't it? In fact, sir told me that you all have finished the very basic question of AC Verma also.
Yes, sir.
So I was expecting you must be getting the answers very easily, but then why you struggle so much? Okay, so all surfaces are smooth. There is no concept of friction. So what will be the acceleration and tension this thing? What is A and T? So can you draw the first again? Do it from basic. Don't apply any excess brain. Just do it from the basic. Draw the ABD, write the laws of motion, and solve it. Just fundamental. Write the ABD, solve the question, get the answer. Do it quickly.
Sir, the that is going downwards, the load, right hand side.
Common sense. You think about it. Like you need to analyze every force and think about it. What will happen? So what will be the ABD? How you will do the ABD? Just don't solve the question. Try to realize the question. That is what I'm saying again and again. That more than solving the problem, what is needed is to feel the situation, to analyze the force, and being able to see every single force is the skill to go with. So getting the accession and tension is not your skill. More than that is, can you see every inch of force, like every force that could be possibly we can draw there. What happened? Why so much time? It is like a problem of worth 2 cents, not more than that. Look at this. So why you guys are struggling? I don't know. When every time I give you a new question, you struggle. You just find the pattern in note, then you solve the question. If the pattern is not onto you, just struggle like hell. What is this? Do you really mug up the every question?
Sir,
What is the answer?
I got, sir, I got T is equal to mg minus mn.
You're saying just anything, whatever is coming to your mind. So there is a surface, there is a block, so it will experience normal reaction, gravity. So now, what is the possible direction of motion for the block? Can it go vertically? No. So the only
Right,
possible direction it can go is left or right. Where it
towards
can
right,
go?
towards right.
Towards
Right side.
now. So I don't know what is the action. Let's call it A. Now, if it will go towards the right, then how the block of mass small m will move?
Down.
Hmm. And with the same acceleration or different acceleration?
Same
Same
acceleration.
acceleration.
So what is the laws of motion for the small m? So for small m, what we should write? Equation.
Mg minus t equals to ma.
Very good. And what about the top block? So what is the equation for the top block?
So t equals to capital Ma.
Very good. So the next step is just add the value. You're done. So it turns out to be small mg equals to A is how much? And once you know the acceleration, you can just use the equation to
Sir,
relate the
the
tension.
first equation.
So T is capital M into A, which is capital M into small m into G by M plus M. That's it. So where was the difficulty? I don't understand like why you're getting stuck in every single problem.
Sir, no, I got stuck in that second equation.
The problem is you are not trusting the laws of motion. You are trying to figure it out by your own some logic. I don't know what you're doing that in your brain. So anyway, it takes time. I'm not an issue. Okay, let's do some simple problem. So we have an inclined plane of inclination angle theta, and we have a block on this plane. And a rope is going over a pulley. Pulley is at the pulley. And then we also have another mass somewhere here. Let's call it M1, M2 by name. Okay. So this could anywhere. I'm taking. Okay, I'm giving you the direction. That's going. This is going down. So find the acceleration and the tension. Find A and T. This time I request all of you, please do the ABD and proceed with the logic, not with your emotion, as I always say. So please try this out. This question. See, if your brain always need some question which you need to see first, then you need to solve. Then there is a problem with your learning process. You need to rectify this because once we learn the concept, we need to just work hard to get the answer through the logic, not through the pattern which you always recognize in variety of problems. And those who learn through only pattern, not by the concept, I mean, you cannot retain the concept for a long time. So you're going to struggle later on actually. So once the chapter is over, you go to the next chapter, you'll forget about the first chapter because the pattern is no longer there. Or you practice so much that the pattern is still there. So the pattern recognition is one good skill, but not very helpful for J advanced part.
Sir, I got the acceleration.
Yeah, tell me the answer.
Sir, my acceleration is m2g divided by m1 plus m1 cos theta.
That's wrong.
Sir, can I send you my answer?
No, I got it. I mean, I know what you made mistake. So what I'll suggest is that again you go back to the concept. So let me again reiterate the concept of which you need to do. In after doing the ABD, the next step is called resolve the forces. So you must resolve the forces along the acceleration and perpendicular to the acceleration of individual block if they are not. So if force is already aligned to the acceleration, leave it. But in case if the force are not aligned to the acceleration, then the rule says first you resolve parallel and perpendicular to the acceleration and then solve the question. So if you follow this particular step, you will get the answer. Can you try again?
Yes, sir.
Oh, right.
Sir, I understood.
Very good. So do it now.
Sir, is it M2G minus M1G sine theta divided by M1 plus M2?
Once again,
M2G minus M1G sine theta divided by M1 plus M2.
that's
Acceleration.
correct answer. That's correct answer. Very good. So you solved it or you solved somewhere?
So, means-
You solved, no? Right.
yes,
So that's the right answer. And then can you find the tension now?
yes, sir.
Go ahead. In laws of motion, for every question you need to struggle, and this struggle will become the asset in the long run. Those who do not struggle in the kinematics and laws of motion, they struggle throughout their life.
Sir, it's M2 times M1G plus M1G sine theta divided by M1 plus potential.
Once again.
M2 multiplied
Hmm.
by M1G plus M1G sine theta divided by M1 plus M2.
So you can take something common. So it's a is you are saying it's a m1 m2 1 plus sin theta into g upon m1 plus m2.
Yes.
That's correct answer. Absolutely correct. Very good. Well done. So you all got the answer.
No, sir.
Why Harshit? What happened? So did you listen what I said? How to attempt any question of locomotion? See, if you read my notes which I shared, I have mentioned the algorithm of solving any problem. So I expected that you guys must go through those notes and the PDF anyway. So I have exactly mentioned that how to thinking, how to start your thinking process. So I made an algorithm to solve any question of automation. It's very simple. The step one is draw the ability. Don't think much. The step two is, in fact, I will say just change the step. You first decide the possible direction of acceleration. Possible direction, like whether it will move or not, that's a different story. But what is the possible direction of acceleration? And then the next step is draw the ability and then further resolve the forces which is along the axis and perpendicular to axis, and that you have to do only for those forces which are not parallel or not aligned to A. And once you resolve the forces, then all the perpendicular force will be balancing each other because there is no accessing in that direction, and all the parallel force you have to write the laws of motion called F net equals to mass into acceleration. And once you do so, you will get the answer. So still, I will say that you again try. I should not solve today now because I have solved every question and now you are getting kind of handicapped. So I'll suggest that you just again retry till you get the answer. And those who have solved it, you can go to the next problem and solve this again. So we have a fixed wedge. The wedge cannot move, so I have made it fixed. And then I introduce one pulley at the vortex. And now we have two blocks, one which can move left and another right down the slope. So I'll just do the okay. So those who have solved the question already, you can go to other attempt and solve this question. You can
So
take
which one
the
is greater? Okay.
just take M. It's not about greater, it's about the force.
Sir, in a previous question, sir, I got AS M2 minus M1 G by M2 plus M1 cos theta.
Harshit, you got the answer?
Sir, I got A as M2 minus M1 into G by M2 plus M1 cos theta for the
I
first
think
one,
no, that's
previous
wrong.
one.
That's wrong. That's wrong. So what are you doing? I don't know what you're doing. Like, are you writing the ABT net force equals to mass interaction for each block?
Yes, sir.
Can you tell
Sir, I
me the
resolved the all the
equation of
plus 9 1 8 8 4 5 6.
sir, for M2 block it will be M2G minus T equals to M2A.
M2G minus T equals to M2A is the right answer. What about the second one?
Sir, for M1 block it will be T minus M1G equals to M1A cos theta.
No, that's the mistake you're doing there. So what is the force of gravity along the acceleration? So how the gravity acts? I mean, I think the possible mistake that you have made is you have taken mg like this. Gravity acts vertically downward, right?
Yes, sir.
Now see the kind of struggle you're going through. So it will have a component this way and this way. And we all know this component very famous. It's m1g sin theta. This is m1g cos theta. You can find the angle and find the component. So this angle turns out to be theta actually. So this is cos, this is sine, and the normal will act like this. So we have done the ABD part, and so the tension will act here. So because this will go down with A, so this will go up the plane with A. So the answer will be T minus m1g sine theta equals to m1 into A. And this will have tension T upward, m2g downward. Nothing to resolve here because everything is properly aligned along the acceleration. So we have to just write m2g minus T equals to m2A. You need to just add the value and you'll get the answer m2 minus m1 sine theta into whole g equals to, in fact, I can divide here that. That's the answer. So where is the difficulty? Tell me.
Sir, I got the answer.
Sir, I resolved the all things M1G sin theta M1G cos theta, but sir, equation forming I'm still lacking.
No, so you need to resolve forces along the acceleration like in that line and perpendicular to that line. And what also you need to realize that every force in the direction perpendicular to acceleration must be balancing out each other. So there is one more equation that you will get called n equals to m1g cos theta, and that is going to be useful in the chapter of friction. So because friction is not there, so normal is of no importance, so we are not taking. Yeah. So now, if you do the same thing here, can you tell me what is the answer here? So now you can do this question, the second question.
Yes.
Sir, I got the answer second. I mean
Tell
acceleration.
me.
Acceleration is equal to
Yeah. Tell me.
g multiplied by
Mhm.
m2 sine theta minus m1 sine alpha divided by m1 plus m2.
That's correct answer. Very good. And you can try for tension also.
So is that only I'm finding.
Sir, I got T. Should I say?
Yes, please.
Sir, my T equals to M2 M1 sin alpha minus M2 square sin beta by M1 plus M2 plus M2G sin beta.
No, you're saying anything.
So my A was the same only, like what there it is written. I just had put the value in
It is very weird because in the denominator there is no angle term, only sum of mass. So in the denominator you must have only M1 plus M2. Can you tell me the equation you're writing for getting T?
T equals to M2A plus M2G sin beta.
Okay, that's wrong, I think. Oh, that is wrong, I think. Check again, that's wrong. Check again.
Sir, I got the tension.
You got the
Tension.
metal?
Second one. Sir, M1 M2G divided by M1 plus M2 multiplied by sin alpha plus sin beta.
Correct. That's the right answer. Okay, so no problem. So what you can do is you can practice sums from my notes from Messurma, from any module text. But one thing which you need to actually command is the resolution of forces, how to resolve forces, and you have to stick to the plan. The plan is net force equals to mass into acceleration. And the second plan in the plan, what we do is we always write the force along the acceleration as positive, called the supporting force, and the force which opposes we take as negative. So if you stick to this plan, then I don't think we will face any difficulty in laws of motion. Now, this is of course not the exhaustive list of problems that we come across. This is called the level 0 problems. So you have just solved the level 0 problems. So the real problem will start from the next level, the level 1, and we go to the level 5. So far, every question which I've solved is like the toy problem. But this will be the fundamental to all challenging problems. And with every problem, you need to understand something more actually, something more complex methods. Now, before I end today's lecture, let me summarize all problem in one go. So now this is called the concept of system. So if you look carefully that in every problem that we solved so far, every block was moving with same magnitude of acceleration, and somewhat the sense was also same. Sense means if one is going down, other is going up, so that's having same sense in terms of thread.
About transmission
Okay, sorry. So what about? So concept of system is one of the the easier way to attack all such problem that we solve in the level 0. So in the level 0 problem, so we'll start with the same Atwood machine to get this concept right. So let me do the from basic ABD. So we have two gravitational pull M1G and M2G acting on the two blocks M1 and M2. So now these are called the pull forces. Now the tension is also a pull force, but we only look for the force which is acting not within the system but external to the system. So if you look carefully, if one goes down, the other goes up. So if I mentally make it horizontal like this, it seems like the M2 block is going towards the right, and this is also going towards the right. So if you just open it, if you make the shape something like this, what you will realize that both these blocks are going in the same direction. Now that is something which gives the sense. So the concept of system says that if you take M1, M2 as system, so taking M1, M2 as system, we have to only look for the pull forces, and we must ignore the internal forces because this is the system. So this is pulled by M2G and this is like pulled by M1G. And because this is my system, so tension becomes the internal effect or force. So I can replace this by entire one single mass called M1 plus M2. And this looks like the force acting this way. So the acceleration we define in this situation is called net pull force on the system divided by total mass of the system. And this will do all the job. And therefore we have the answer. What is the net pull force? One is pulling right, one is pulling left. So we can say net pull force is M2G minus M1G, and net mass of the system is, and so we have the answer. And now let's go back and solve the question. So we can write directly. Here the pull force is M2G sine beta, but it is pulling, or in fact it is opposing the motion M1G sine alpha, because both the gravity is against each other. So we can say net pull force is how much? M2G sine beta minus M1G sine beta alpha upon the mass which is getting pulled is the total mass of system, and so is the answer. You can apply the same concept here, apply the same concept here, and every other question you can apply, the same answer will come. Now this is the shortcut to all of the problem of level 0. That's why I said this is level 0, because generally we get all these answers mentally. So if I give you any problem in which acceleration is same for both the object, You can just do it mentally, maybe in one line. So let me just do it one more problem to end this topic today. But not this. Now I want all of you to get this answer without much difficulty. This angle is, let's say, it's theta, M1, M2, M3, and let's say it's going this way. Can you find the acceleration in one line or any number of lines? Doesn't matter. So what is the A here? Remember, we have to find the pull force, net pull force by gravity only, and all tension becomes internal if I take M1, M2, M3 as system.
Sir, is it M1G plus M2G sine theta plus M3G divided by M1 plus M2 plus M3?
So all will be supported. Are you sure?
What, sir?
So are you adding all values or is there a difference also?
Sir, I will check.
So gravity is acting on M3 downward, M1 downward, and here gravity will have a component this way, which is going to pull. So what is the net pull force? What is the net pull force? Tell me. You can see that the M1G is supporting the M2G sine theta, but M3G is opposing it. It's not trying to go that. So the net is
M1G plus M2G sine theta minus M3G
Sir, I'll
divided by
understand.
M2 plus
yes. Now this is the difficult, or you can say the most difficult part of the problem of the SC Verma, but you can see that with this idea we can solve in one line. Okay, so I hope all the problem of level 0, I mean level, why I say level 0, because this defines one particular property, you can solve like this. Let me just wrap up the lecture with last problem. M M1 so what is the acceleration? Let's say this goes this way. What is the acceleration?
Sir, it's M2G plus Mg minus M1G divided by M1 plus M plus M1 plus M2.
You will never get this chapter, I think. I mean, this is going to be the hell lot of difficult for you guys because you are not able to realize anything. Anyway, all the best practices. Let me write the answer. That's so the pull force is only 2 force because gravity here is acting this way, and I think this gravity will never pull any mass, isn't it?
Yes, sir.
So before you say anything, you should realize because what I have realized about you guys that you believe in the pattern and you repeat the pattern, you don't understand the concept at all. So good luck with your method of learning, and I really wish that you mend your ways to learn in the right way. All the best.
So this class over.
Yes. Yes.
Sir,